Alright, this is a video for 3HT, Chapter 8, Exercise 27. This is the beginning of paragraph 8.3. The question is, we see three tables, here, there, and there. The top one is for the years, like 0 years, 1 year, 2 years, and 3 years. And at the bottom you see a number. The question is, which of the following tables show exponential growth? So if there is exponential growth, then there must be a growth factor. What that means is that if you go from 8 to 12, you multiply with a number. So I can do 12 divided by 8, that's 1.5. So here you multiply with 1.5. So the growth factor is 1.5. Now if the growth factor is the same if you go to the next year, and if it's also the same if you go to the next year, then it's exponential growth. If you get a different number, then it's not. So let's calculate what 18 divided by 12 is, and that is also 1.5. And if you calculate what 27 divided by 18 is, so this one divided by that one, that's also 1.5. So you see that the growth factor in this table is the same everywhere. Now if it's the same everywhere, in this case it's times 1.5 times 1.5, then it's exponential growth. If these numbers are different, because the last one could have been 1.3 for example, then it's not exponential growth. Now, there's one thing that I need to say about this also. Sometimes these numbers are rounded off. So these can be off by a tiny bit. So here you get 1.5. So the next one could have been 1.49. But it's so close to each other that you can still say it's exponential growth. Okay? But here it's all exactly the same. So this one has exponential growth. Let's take a look at the second one. Here we also go from 8 to 12. So also here the growth factor is times 1.5. But we can already see that this one does not have exponential growth because the other one had 18 here and this one has 16. Now if you do 16 divided by 12, you get 1.33. So that's a different growth factor. So this table does not have exponential growth. But there's actually something else going on with this table. Because here the increase is just the same everywhere. Here it's plus 4, here it's plus 4, and here it's plus 4. So it's actually a linear table, right? Here the difference is different this time. It's plus 4, plus 6, plus 9, and here it's plus 4, plus 4, plus 4. So this one is linear. Yeah. Then we're going to go to the third table. Here we have, it says 50, 60, 72, and 86.4. So if you want to calculate the first increase, you do 60 divided by 50, and then you have 1.2. So if the other ones are also 1.2, then it's exponential growth. So here you have 72 divided by 60 is also 1.2. And if you calculate 86.4 divided by 72, you also get 1.2. So this is exponential growth times 1.2 times 1.2 times 1.2. So the first one and the third one have exponential growth. That was question A. Then question B is generate the formula n for each table showing exponential growth. So for the first table, we have to make a formula. Now the formula always looks like this. N equals the starting value times the growth factor to the power of t. Okay. Now the starting value, you can just see that in the, or actually in the book they call this the initial quantity. Maybe they also use an I there, I don't know. They usually use a B. So the first number here is an 8, so I'm going to write that down here. The growth factor is 1.5, we calculated that, and then we do a t there, so n is 8 times 1.5 to the power of t. Okay. The second one, we don't have to make a table, don't have to make a formula for that, but we can, if you want to, because it's a linear formula. So here you get n equals, and then it starts at 8, so plus 8, and then every time it's plus 4, so 4t plus 8, that's the linear formula. But you learned it in chapter 1, right? Then we have this. This is also exponential growth. So we get something like b times g to the power of t. So n is the initial quantity is 50. The growth factor is 1.2, and the t is just the variables, is the letter that you have in this formula. So this is the answer for both A and B. Thank you for watching.